Greetings, everyone. Thank you for your time and consideration to go through this particular video and the assignment that we have done. So, introducing ourselves, this work is done by Group 1 for the project of the course INDE 6332 Engineering Project Management. So, starting off with the presentation, I'll be explaining you about the schema. We'll basically introduce you about the project team, project work, and also the team members, followed by the visual parameters of the project and also the selection factors which the entire team has come up with, and the scoring methodology that we have deployed for coming up scoring the final vessel configurations. Post that, we'll be looking at the final scores of each of the vessel configuration, followed by the final vessel configuration that we have attained. Proceeding forward, so basically the project is to select and construct a small marine research vessel as per the RFI given in by the Texas Parks and Wildlife. So the scope of this particular first assignment is to select and finalize a vessel configuration on basis of constrained weighted model. So this work is basically done by Group 1, myself, Nihar Sabani. I'm the project manager, and my team members are Abu Jarad Hazaifa, Ayala Arturo, Deka Anup Kumar, Haq Asanul, Kottagundla Aditya, Nito Ricardo, and Ying Zunye. So proceeding forward, basically the vessel parameters for this particular research vessel are size of 34, 36, 38, and the hull material options are aluminum and fiberglass. The engine options are single diesel and twin diesel. And coming to the cabin size, the options we have or the parameters we have are half cabin and three-fourth of the cabin. On basis of this, we have come up with 24 vessel configurations, and we will be rating all 24 vessel configurations on using the constraint weighted model. So as a team, we have done our own independent research, and collaboratively, we have come up with these 5 selection factors for scoring the vessel configuration, and they are initial investment, operating cost, maintenance and repairs, durability and customizability. So moving forward to the scoring methodology that we have used, we as a team, 6 members of the team have done their own independent research, and they have rated the 24 vessel configurations on basis of our independent research. We've rated the scores individually against each configuration for initial investment, operating cost, maintenance and repairs, durability and customizability. And these are the, as you can see on the score screen, these are the average scores for each of the configuration against each of the selection factor. So once we've done that, we've carried our work with, identifying the constraint minimum and the constraint multiplier. For that, what we've done is we've given in our priority scores independently, and we've come up with average scores for each of the vessel parameter, vessel factor. You see, for initial investment, it's average score of 3, operating cost 4, maintenance and repairs 4. It's like that. So we've done our research, and on basis of that, we've come up with a constraint minimum of 2.5. On basis of 2.5, the constraint multiplier for all the 5 selection factors is 1. Post that, we've also done our work to given the normalized weight and the percentage accountability for each of the factor on an overall basis. So for initial investment, it's 18%. For operational cost, it's 21. Maintenance and repairs being at 18%, durability being at 23%, and customizability at 20%. So once we've done the scoring of the vessel configurations, coming up with the constraint multiplier and the normalized weight factor, we've used the final score of vessel configuration formula as, summation of the constraint score of the factor multiplied by the weight and multiplied by the factor score for each of the factors. So by the help of this particular formula, we have attained at the final scores of each of the vessel configuration. So as you can see on the screen, these are the final scores for each of the vessel configuration on basis of the formula that we've used, and also on basis of the scores that we've given initially, the constraint minimum, the factor weights. So with this particular formula and the scoring that we have done, we have arrived that the final vessel configuration should be the configuration 2, which is size 34 with hull material as aluminium, single diesel engine in three-fourth of the cabin, having the highest score at 3.73, And this we have decided to be the final vessel configuration for the project. So yes, the final vessel configuration for the project is size 34, hull material aluminum, engine single diesel engine, and 3/4 cabin size is our vessel configuration post the work that you've done and the vessel scoring configurations that we've done using the constraint weighted model. And we're looking forward for the coming assignments. And in the next assignment, we'll be doing the cost comparison, cost analysis part for the research vessel that we are planning to do. So that would be all from my side. Thank you for your time and consideration. Have a good day.